when you enter into the plane, you put your life into the hands of the plane manufacturers. Because really this plane runs on software. If this software fails, people die. We write software as well, although if our app in the browser crashes, probably nobody dies. But anyways, we want those apps to be robust and reliable. So we write tests. You see, the difference is that we as a front-end community have little experience writing tests. Because front-end development for a long time was just a simple HTML and CSS and maybe a little bit of JavaScript to add a snow on a web page. And nobody tested it. So, but in the meantime, those other communities in the programming world were writing complicated logic and testing it thoroughly. So they have a lot of experience, and we can learn something from them. So today I'm here to tell you about testing technique that I learned from other communities, and I see a few front-end developers using it. And it proved itself to be super useful when testing UI and state machines. So let's talk about how we usually test our apps. Usually, we tell stories. We tell like, once upon a time, there was a sort function. It took an array of 3 and 2, and it returned an array of 2 and 3, and it lived happily ever after. And that's good. This is called example-based testing. And those kind of tests are easy to write, easy to read, and are good because they tell stories, tell anecdotes about the code. And stories is the most effective way we communicate as people. Stories resonate with us, makes us moved, makes us feel something, makes us connected. So those tests are good. But those tests also have drawbacks we seem not to address, really. First of all, those kind of tests do not tell you what is important and what is like randomized data that somebody put. Like, does it matter that there is 3 and 2? Or do they have some meaning? Or can we put other numbers there? What about negative numbers? Can we put them there or not? And how do you come up with this data anyways? Like, do you roll a dice? Or ask a friend to count in his mind until you say stop? Like, you know this rule, garbage in, garbage out. Meaning, the best, like, the quality of the output of any system is only as good as the input you give to it. And how would you judge the quality of such a test? Like, this input is garbage. How do you expect reliable tests with something like this? But probably the worst crime example-based tests do is that they do not deliver on the generality they promise. Like, take a look at the name of this test. It says sort function should sort integers. But this test does not prove it at all. It only proves this sort function works for numbers 3 and 2. And that's it, nothing else. So there was this guy, he was an early pioneer of computer science, Edgar Dijkstra, and he wrote that testing shows the presence, not the absence of bugs. Now, example-based tests show you the absence of bugs. They try to lure you into believing that there's everything okay if it works for those couple examples you came up with. And you might think at this now, that's great, Maciej, but you know, I write more examples and they are better. Okay, good. Good that you write more examples. But first, writing many examples is boring, hard to maintain. And second, it only allows you to deal with edge cases you know, or you could came up with. But you see, bugs are not where you expect them. If they were, you would find them. Bugs are where you do not expect them. So it's not about how you deal with edge cases you know or you can come up with. It's about how you deal with edge cases you don't know. And by the way, would you like planes to work like that? Like, we tested this plane in 2 different scenarios and it worked. So it will probably work okay and you can fly it. Would you fly? So what can we do about our current state of testing in front-end development? Like, where do we even start? So this is the example I showed you earlier. And we are going to remove the assertion. And yeah, we mentioned the poor quality of inputs we give to our tests. Let's try to start there. Like, instead of using our minds to come up with these examples, let computers do the hard work. Let's employ computers to generate the input data. So this is the pseudocode for now. We implement the generate function that generates some inputs for us. And we tell this function, please give me an array of integers. Now, we also say, then take this function that I give you, give it this generated data, and I will write stuff here. I will write assertions. So first, we can simply call our sort functions with this randomly generated data. And here, what you can see here, my friends, is called fuzzy testing. Fuzzy testing means you provide some randomly generated data, and you see if the function throws. If it throws, if it breaks, then no luck. But it's not very useful in our case. We can do better. So let's try to write an assertion. We expect the result of this sort function with some random data to be what? Like, if the inputs are randomized, we can no longer provide an example of the output and compare it to, because the output will be different every time. So what do we do now? Now, enter the world of properties. What is a property, my friends? Property is something that is always true, no matter the inputs. Property is something that is always true about our output, no matter what input we give. And if you are confused at this moment, I invite you to do a little thought experiment with me that will show you that you think in terms of properties right now. Like, you are able to do this. Did it ever happen to you that you ordered something in the restaurant and you received something else? Yes, sure. So let's imagine you enter the restaurant and you order a toast. You pay for the toast, wait a couple of minutes, and the waiter brings you this. Doesn't look like a toast, does it? So you say like, hey man, it's not a toast, I ordered a toast, please give me a toast. And he's like, oh, I'm sorry, I made a mistake, I will bring you a toast in a couple of minutes. And then he brings you this. And you're like, what the heck, man? Like, I ordered a toast, could you please bring me a toast? Yeah, like, sure, I'm sorry, it was just a mistake. And he brings you this. At which point, you're considering leaving the restaurant and leaving a bad review somewhere over the internet. But okay, you're trying to be nice and you're like, okay, this is not a toast. I paid for it. Please bring me a toast. And he brings you this. No, it's not a toast. Maybe it could make a toast, but not really. So you give him another chance, the last chance, and finally, you receive the toast you paid for. But I want you to realize one thing. You didn't know how the toast will look like until you received it. But you somehow figured out that what you received earlier was not a toast. How did you do this? Properties, yes. Exactly. So you know some properties that a toast should have, and you figured out those earlier things didn't have those properties. What were those properties? Let's run through one again through those examples. Here, what's the problem here? It's a type problem. It's not a type of food we ordered. It's a fruit. Okay, here. Yeah, no, nothing. It's an emptiness problem or a presence problem. It's a property. Here? Yeah, size, exactly. And if we speak about arrays, we can also say length. And here? Aesthetics, okay. Shape. You can assume that a shape of the output should be certain, and you can check the shape of the output, no matter the input. So let's take those properties and try to apply them to our tests. Type. Obviously, we want to sort an array, and we want an array back. So we check if the result is an array. This also covers for emptiness, because undefined is not an array. Let's move on. Size. We want the sorted array to have the same number of elements as the unsorted one. We do not want any elements missing or added. So that's the size. Shape. We want to sort numbers. So we want every element in the sorted array to be number as well. So we iterate over every element, and we check if it's a number. Now, there are two additional properties that I came up with for this function. Those are, we want every other element to be greater than the previous one, greater or equal than the previous one. So we iterate over all elements. We take the next one, if the next one exists, so it's not the end of the array, we check if it's greater than the current one. And one more. We check if the sort function is idempotent, meaning if I sort the array once, then no matter how many times I call this sort function on this sorted array, I always expect the same equal array. So I sort it 2 times, and I want it to be the same as sorted once. And congratulations, we just came up with properties for property-based tests for our sort function. Let's come back to generators. Now, because we have generated values randomly, and we have properties that are always true, no matter the input, then we can run those tests how many times we want. We can run it once, 2 times, 10 times, 20 times, 100 times. It should always pass. And the more times we run this test, the more certain we can be that it works for a lot of examples. So we implement run multiple times function that runs the test 100 times, for example. Now, notice also that you need no framework whatsoever to write property-based tests. You just have to come up with properties, write some generators, and you can execute those tests multiple times. But since libraries for property-based testing exist, it's useful to use them. They do stuff for us. And the library, there are a few implementations in JavaScript. The one I like the most is FastCheck, because it has very approachable API. It does not, like documentation, it does not only document the API, but also explains a lot of things along the way, and tells you why and how to use things. So let's import FastCheck here. And the equivalent in FastCheck for our run multiple times function is fastcheck.assert. We run tests with fastcheck.property, and we generate random inputs with generators for, in this case, for array and integer. And that's it. And should your test suite for sort function look like this, or does it miss something? assuming we have assertions written. We miss examples. Like at the beginning, we thought examples are good. They are good. They are easy to read, easy to write. They tell stories, like easy to understand stories. So you already write them. Keep writing example-based tests. They are good. But also complement them with property-based tests. So how about running this test? Shall we? Would you like to give it a try? Let's do it. Whoops, it fails. Oh no, too bad. Now, should we cry or be happy that it failed? What would you say? Mixed opinions. Deadlines. Okay. Yeah, deadlines. Just run it again. Maybe they will not come up with this input anymore. Yeah, look, writing property-based tests is like buying an insurance. When you buy an insurance, you bet and you say, I bet my apartment will be on fire next month. So I'm happy to pay you a small amount of money. When it is on fire, you will pay me back more. And you're happy to lose this bet. If your apartment is not on fire, you're happy, right? Same with property-based tests. It's like, say, for this function, any input you give, I expect it to give me certain output. Now, computer, go and prove me wrong. And I'm very happy to lose this bet. Because if I lose this bet and test fails, then I either encountered a bug in my implementation, or I encountered a bug in my way of reasoning about the code, which both are valuable and I learn. Continuing this on this example-based testing would be like saying, oh, my apartment wasn't on fire last month, so it will surely not be on fire next month, and not buying an insurance. Anyway, you learn from failures, and you only fail if tests fail, you don't. You fail when tests doesn't, and bugs find their way into production. Then you failed. Okay, so let's take a closer look at this report. What's important here is this. This is counterexample, meaning an example that you can run your function with, and your properties will fail. How did FastCheck come up with this counterexample? It generated a lot of mess, and it was good for finding a bug, but it's very, very hard to debugging. Like, if you would receive the first line here, whoops. If you would receive the first line, good luck. Have fun debugging, finding what's the problem with. So what FastCheck does for you, it tries to shrink this, like tries to come up with minimal example that still fails your test. And that's how it came up with 10 and 2. And this is one of the most important features of libraries for property-based testing, and this is called shrinking. So we know that it fails for 10 and 2. What do we do now? What would you recommend? I'm sorry? Try to fix, but first, take this and write an example-based test for it. Why? Because it's FastCheck generates data randomly. We can never be certain it will generate the same case ever again. So if we want to be safe against regressions, that this bug never happens again, we have to write an example-based test for it. And we go and fix it. Okay, you might think at this point, okay, in theory, it sounds interesting, maybe I will give it a try, but is anybody using it at all? Like, yes, people are using it. Big companies are using it. And there is a case study from Google. They have this library, C++ library, called LevelDB. It's a key value store, something like Redis. And they developed it and then created property-based tests for it and ran. And they found a bug that required 17 actions, 17 steps to reproduce. Like, do you think any quality assurance specialist would come up with those exact 17 steps and find a bug? Yeah. Okay, fine. Later on, they found a bug that required 33 steps to make this library working incorrectly. It's almost impossible for a human to come up with this. Spotify also used property-based testing. They have this module written in C++ that was responsible for scheduling playlists, shuffling tracks, repeating playlists. And what they found is, this is a playlist. That was the minimal counterexample. You have a playlist, you enable repeating on the playlist, you put a track, you play it, then you put another track at the beginning of this playlist, and then you do next. And you would expect that the track B is now played. But what happened was track A was played from the start. And it appeared in the C++ library, but it was also apparent on Android and iOS devices as well. At this point, you might think, okay, Maciej, but does it work in the front-end world? Yes, it does. Do you recognize this library, React Final Form? Yeah, it's more and more popular recently. It is the successor of Redux Form. So the story goes like this. A guy implemented Redux Form, maintained it for a couple years, closed a couple hundred issues, pull requests, got a lot of experience in creating forms in React. And then he realized Redux is not the best place to store form data, and since I have so much experience, I can create something better. And that's how he created React Final Form. Now, this library has 100% coverage with example-based tests, more than 3,000 stars on GitHub, and more than 33,000 weekly downloads from NPM. Also, this library comes with an add-on called React Final Form Arrays, which also has 100% coverage with example-based tests, and more than 11,000 weekly downloads from NPM. And what this add-on helps you to do, if you have this kind of array-like data in forms, it helps you manage it, like add a row, delete a row, change the order of those rows, stuff like that. And it does it by providing 9 utility functions that you can call mutators that you can use and plug, and it works. And I decided to write property-based tests for this add-on. What I found was 6 new bugs, and those tests were already able to reproduce 4 already existing issues opened in this repository. Now, the takeaway is, if we as a community would be more aware of those kind of functional tests, and we would write them beforehand, those 10 bugs would never find their way into our production applications. So, 7 out of 9 those utility functions contributed in this or other way to those bugs. I was also able to reproduce those bugs in the browser, playing with the form. The reports looked something like this. By the way, I used a technique similar to the technique that Spotify used to find bugs in their playlist scheduler. Basically, the technique is that you randomly generate commands. Commands meaning ways, things that a user could do in your app, like randomly, with random attributes, and you just throw it on onto your real system and onto the model you created, and you check if those match. So here we can see that we start with just one row, one empty row. Then the command is change the value at index 0 to some string. And then the next command is unshift, so add the field at the beginning with some data. And we can exactly see what's not matching in the state of this form. Yeah, so takeaways. Write example-based tests, they are good. Tell stories, easy to read, easy to write. And if failure is not an option, like in planes, then complement them with property-based tests to be like double check. And to let computers help you find bugs instead of lure you there are no bugs with examples you came up with, and play safely.